Hello everyone, in this video we will be discussing about the previous year question of theory of computation and compiler. This is the fourth part of the playlist and this is the last part of compiler. So let's move on to the question. If L and L dash are recursively enumerable, then, okay, it is given, we have given two language L and it is said that L is recursively enumerable. Okay, so if L is recursively enumerable, it means that there exists a Turing machine. Okay, there exists a Turing machine that accepts all strings in L. Okay, that accepts all strings in L. And it is also given that L dash is also recursively enumerable. That is, if L bar, L complement of L, if it is recursively enumerable, that is, there also exists a Turing machine that accepts all strings in L bar. Okay, so that is, if the string is in L or not, that is the string which belongs to L and the string which does not belong to L. Even if the string does not belong to L, there is a Turing machine that accepts it. Okay, that is all strings. If the string it belongs to L or string it doesn't belongs to L, it is accepted by a Turing machine. We have a Turing machine that accepts all the strings. So the language is recursive. Okay, so the answer is D. Okay, next. We have given a production rule. The language generated by the following grammar over alphabet A and B is a set of. Okay, we have to see that what is the language generated by this. Now let us start with S. S is A, S, A. From here I have taken it. Okay, in case of S I can write B, S, B. So that is A, B, S, B, A. Okay, in case of S I can write A or B. See, this is even number, this is even number. So even plus even is even, but always there would be a center element. Okay, so it makes us odd. So even plus 1 is equal to odd. So it would generate all the palindromes of odd length. Okay, it would generate the palindromes of odd length. If there was a production like epsilon, okay, then we can say it generates both with even length as well as odd length also. What is the highest type number that can be assigned to the following grammar? So we are here talking about the type. Now let's see what is the type. Okay, so type 0. So we'll start from type 0 or type 3. Okay, type 3 is regular grammar. Regular languages, they come under type 3. Type 2 is context free languages. Okay, and type 1 is context sensitive languages and type 0 is unrestricted language. Okay, the regular languages, these are identified by NFA or DFA. Okay, and the context free languages, these are identified push down automata. Context sensitive languages, these are identified by linear bound automata. Okay, linear bound automata or LBA, you can say it as LBA. And the unrestricted grammar, they are recognized by the Turing machine. Okay, now let's see the highest length of grammar which can be generated by this given production. So we have S is AA. If I substitute A over here, we have B, AA. Okay, if I substitute B over here, we would be having A, B, C, AA. So this is finite language. This is a finite language. So if the language is finite, then it can be represented by a DFA. It can be represented by a finite automata. So language which is represented by the finite automata is of type 3. So the answer is type 3. Okay, next. Access time of symbolic table will be logarithmic if implemented by, okay, whenever we have a linear list, the access time would be linear, that is order of n by 2 would be the access time. We can say it as order of n. When we have search tree, it is order of log n. When we talk about, so the answer is B. Hash table, it would be generally order of 1. So the answer is B, that is for symbolic table with logarithmic would be logarithmic if we use search tree. Okay, next question. A top-down parser generates. So for this we have to see, we generally talk about top-down parsers and bottom-up parsers. Okay, top-down parsers are LL parsers and bottom-up parsers are LR parsers. Okay, so this is the first L is scan the symbol from left to right. Okay, and the second symbol, second L, it is for leftmost derivation. Leftmost derivation. Okay, in case of bottom up parsers, that is LR parsing, that is scan from left to right. Okay, and R is rightmost derivation in reverse order. Rightmost derivation in reverse order. Okay, so we are talking about top-down parsers. In top-down parsers, it is leftmost derivation, that is C. Okay, so the answer is C. Next. A simple two-pass assembler does which of the following in the first pass? So we have to check what the two-phase processor does. So there would be two phases. We'll be discussing about both the phases, first and the second phase. In the first phase, it would count how long the machine code instruction would be. Okay, it would count the length of machine code instruction. Okay, and it would create a table, that it would create a symbol table. And it would allocate space and it would allocate space for literals. Okay, now let's see our option. It builds a symbol table. Yes. It allocates space for literals. Yes. If check the instruction are legal in the current assembly mode. Yes. All of these is done in the first. So answer is all of these. In the second pass, it would do only one thing, that it would generate machine code. So you have to remember, in the first pass it makes symbol table, in the second pass it generates a machine code. Okay, next. What is peephole optimization? Okay, peephole optimization is a form of, we have options. Now let's see what is peephole optimization. Suppose we have a program or we have a code of 10k lines, 10,000 lines. So what does peephole optimization do is, it would take only small set of instruction, maybe 50 lines. Okay, and this 50 lines would be called as a peephole, and it would optimize these 50 instructions. So what we are doing is, we are locally optimizing few set of instruction in peephole optimization. So it is local optimization. Okay, next. Given the following statements, so we have two statements, S1 and S2. So let's see what is the answer. We have every context sensitive language is recursive. There exists a recursive language that is not context sensitive. Now let's see it with the help of a diagram. This is a diagram. So, okay, so every regular language is context free, every context free language is context sensitive, and every context sensitive language is recursively enumerable. But we are talking about recursive languages. So recursive language would be somewhere over here. But it is true that context sensitive language is a subset of recursive language. So every context sensitive language is recursive is true. So S1 is correct. There exists a recursive language that is not context sensitive. Yes, if language L1 is there, this language would not be context sensitive. So this is also true. So both S1 and S2 are correct. So D is our answer. Okay, so you have to remember this diagram. Which one of the following is false? Okay, there is a unique minimal DFA for every regular language. Okay, Next, every NFA can be converted into equivalent PDA. Okay, and third is complement of every language of context-free language is recursive, and every non-deterministic PDA can be converted into deterministic PDA. Okay, see, a power of deterministic PDA, it is not equal to non-deterministic PDA. Okay, both the power is not the same. So deterministic PDA cannot handle the language or grammar with ambiguity. If the language has some ambiguity, DPA cannot handle, but non-deterministic PDA can handle. So every non-deterministic PDA cannot be converted into equivalent deterministic PDA. So this is the false one. Okay, next. If L and P are two recursively enumerable languages, then they are not closed under. Okay. So recursively enumerable languages, these are closed under, we can write, these are closed under clean star, concatenation, union, and intersection. That is, these are closed under these four things: union, intersection, concatenation, clean star. So this is true, this is true, and this is true, and this is the answer. It is not closed under set difference or complementation Okay, so the answer is D. Okay, next. In some programming language, an identifier is permitted to be a letter followed by any number of digits. So it can be like the first has to be a letter, okay, and the second, it can be followed by any number of digits or letters. If L and D denote the set of letters and digit respectively, so which of the see, this is the answer. How? Let's see. It is the first number is letter, so letter is fixed. Okay, and the second is, it can be a letter or a digit. It can be any number. Okay, so it can be any number from 0 to from 1, from 2, from 3, any number of letters. So we can put clean star over here. So this is the answer, which is C. Okay, so this was all about the questions of TOC. If you like the video, please click the like button, and for feedback or any queries, please send your mail to l3learnlead@gmail.com, and please do subscribe to our channel. Thank you.